First of all, this is introduction for our project. Lignocellulosic biomass can be a potential source of bioethanol by a microorganism such as yeast and bacteria. Hydrolysis of cellulose can be in reducing sugars and fermentation of sugar produce bioethanol. The production of bioethanol from lignocellulosic material comprises three main stages, starting with a pre-treatment, followed by an enzymatic hydrolysis step where fermentable sugar are obtained for the final fermentation process. Several investigations have been carried out in different bioreactor configurations with the aim to obtain higher yields of glucose in the enzymatic hydrolysis stage. However, the commonest use are stirred tank bioreactor. Then we have three main objectives for our project. First, to determine the appropriate type of bioreactor to produce bioethanol. Second, to identify the production of bioethanol using fermentation method. And the last one is to determine the advantages of using bioethanol to consumers.
Okay, for this mini project, we will produce the product bioethanol and using biocatalyst, which is enzyme immobilized, and substrate, which is lignocellulosic biomass. The types of bioreactor we will use in this mini project, which is stir tank bioreactor, or we known as STBR. Why we use STBR? Because they can provide a better aeration and mixing properties. They also can provide the high temperature during operations, while they're very easy to operate the solutions in produce the bioethanol. Like we know, the component in bioreactor like motor, pH, steam, viving part, filter, cooling jacket, impeller, baffle, culture broth, spager, cooling water in and cooling water out, sterilize air, valve, and harvest. Like we know too, the stirred tank bioreactor is a conventional and the most commonly used type of fermenter in microbial bioethanol productions. Stirred tank reactor also can operate either in batch mode or in continuous mode. In produce the bioethanol, we are using batch mode. The batch mode is widely used in the production of bioethanol process and is preferred in several industries. In this operation mode, the substrate is initially loaded to the bioreactor without additional feeds or removal of substance from the system, or we know as closed process. So, the batch operation mode implies that the volume remains constant until the end of the reaction.
So I will explain about MOHD design for our bioethanol production by lignocellulosic biomass. So our group used yeast-based fermentation because it is commonly used for bioethanol production. A sugar-based or carbohydrate-rich medium such as molasses, corn syrup, or glucose. The sugar solution is inoculated with yeast, and the yeast ferments the sugar into ethanol over a period of several days. Several factors that influence the efficiency and yield of ethanol production is sugar sources, pH level, temperature, nutrient composition, and inhibitors. So I'll go with sugar source. The type and quality of the sugar source can affect the rate of efficiency of fermentation. This is because high quality sugar sources with a high concentration can easily fermentable sugars with such as glucose and fructose, so it can lead to higher yields of ethanol. Next, I will go to the pH level. The optimal pH level for yeast fermentation is around 4.5 to 5.5. pH level outside of this range can inhibit yeast growth and ethanol production. As for the temperature, yeast-based fermentation typically take place at temperatures ranging from 25 degrees Celsius to 35 degrees Celsius, with optimal temperature depending on the yeast strain that been used. As for the nutrient composition, yeast requires a variety of nutrients including nitrogen, phosphorus, and minerals to grow and produce ethanol. The addition of the yeast extract or concentrate liquor can provide these essential nutrients. As for inhibitors, certain compounds such as organic acids and high concentration of ethanol can inhibit yeast growth and fermentation. Care must be taken to avoid high levels of inhibitors in the growth medium. A well-designed yeast-based fermentation process can lead to high yields of bioethanol with low level of byproducts and contaminants. This can be further optimized by using specialized yeast strains and controlling process conditions such as temperatures and pH level.
For methodological, we have 4 processes. First, pre-treatment. In this section, it is divided into 2 types, which is physical pre-treatment and also biological pre-treatment. Physical pre-treatment consists in the combination of the lignocellulosic biomass, which they aim to reduce the particle size and the crystallization of the biomass by mechanical methods such as milling, grinding, or chipping. Meanwhile, biological pre-treatment is resection and environmentally friendly alternative that combines the use of microorganisms, mainly fungi. Second is enzymatic hydrolysis, consists in the degradation of polysaccharide in aqueous catalyzed by enzyme or acid, run by chemical enzyme process with higher efficiency, low energy consumption due to the requirement of mine operation condition. The next one is fermentation and distillation. Conversions of monomeric sugar obtained in the enzymatic hydrolysis into bioethanol. Distillation is also required to separate bioethanol from water. Last part is bioreactor design. This part is very important to produce bioethanol. Selection of bioreactor should be emphasized for the productions of quality product.
And the last one in this project is conclusion. We are opting to achieve and obtain all of our project objectives by determining the appropriate type of bioreactor to produce bioethanol, which is zero-time bioreactor. We can also identify the production of bioethanol using the fermentation method and can also determine the advantages of the use of bioethanol produced for consumers. Namely, that it is renewable and reduce GHG emissions more than 71% compared to fossil fuels. Bioethanol can also reduce emission of other pollutants, improving water quality. It is biodegradable and has low toxicity.